Alright, so we're going to do a multiplication and division of numerical base exponents. And when we have multiplication and division, the method is very simple and straightforward. First and foremost, we look at our prime base, the numerical values of the prime base, and we check, is the relationship really division and multiplication? In other words, if you look at the numerical bases, you have 50 to the power x plus 1. This numerical base is basically divided by 2 to the power x plus 1. So the relationship between these two is division, and the relationship between these two is multiplication. And there's no addition or subtraction between the numerical bases. So the suggested method then is that first and foremost, we need to factorize, prime base factorize, convert the composite number bases to prime numbers. Okay, and usually we can do this very simply. If you have a Casio calculator, you simply take the number, you press it into your calculator, you press equal, you then press shift, then you press fact. And what you do get is that when you take this number, which is composite, you do that, put 50 in your calculator, you press equal, you press shift, you press fact, then you do get 5 to the power 2 times 2. Please then put that in brackets, and then you write the exponent binomial on the outside of the bracket over. Now 2 to the power x plus 1, the base is already prime, so we don't need to do anything there. We put the dot to signify the multiplication relationship between the 2 and the 5 base. Then we do the same thing. We press 25, we press equal, we press shift, we press fact in our calculator, we get 5 to the power 2. That's if we don't know this mentally. And then we proceed to write the expression external to the bracket. Then the next step is that this base and this base, applying this law, which I'm sure you guys should know by now, that if you have a respective base within a bracket and the relationship is multiply, you can then distribute the exponent for each respective base to the external exponent. So that's why m gets multiplied by p, and respectively for the base b, the n gets multiplied with p as well. There is a law that suggests such. So we have to take then these respective bases. We start with base 5, we multiply 2 and the x, we get 2x. And the common error that learners do make is that they omit to multiply the 2 with the 1. So make sure to distribute the exponent to both the first and the second term of the exponential expression, which is very important because this is a monomial, meaning one term 2 multiplied by a binomial. And when you did that in earlier grades, you knew that you were supposed to distribute by multiplication 2 times x, 2x, 2 times 1, then you'd get positive 2. Then you proceed to move on to the 2 and you do the same thing. 2 is raised to the power 1, you don't see that 1, but that 1 gets multiplied to the x, so you get 2 to the power x. The 1 gets multiplied to the 1, you get plus 1. Okay, I hope that makes sense. Over, we have that 2 to the power x plus 1, which was initially there. Then we have the 5 to the power 2. You do the same thing, monomial times by a binomial. You distribute the 2 to the x, you get 2x. Distribute the 2 to the 2, you get 2 times 2, which is 4. All right, and honestly speaking, this is where I think learners tend to lose marks, because they omit this distribution and they do it incorrectly. But if we do it correctly, then we can move on to the next step, which is we need to apply law number 1 and 2, which speaks to when you have the same bases in the same area. Okay, the numerator, you can basically keep the base of and add the exponents. But if you are dividing same bases, then you keep the base and you subtract the exponents. So now we have 5 to the power 2. So what we'll do is we'll collect all the bases with their respective exponents, applying law number 1 and 2. Okay, and something to note then is that 5 to the power 2x plus 2 is in the numerator already. It retains the exponential signs that were there, both respectively positive. If we go to the denominator, we have 5 to the power 2x plus 4. We know that we're supposed to, as we divide same bases, we subtract the exponents. Now remember, when you apply the subtraction, you are applying it to a binomial, which is 2x plus 4. So the negative sign needs to be distributed respectively to the exponential 2x plus 4. So when we do that, we just suggest that the sign for each respective term changes. Okay, because this is like applying negative to 2x plus 4. Remember, when you do that, you are distributing the negative to 2x and you're distributing the negative to the positive 4, hence the sign change. Okay, and then times 2. Now you collect the exponents for base 2. 2 to the power x plus 1 in the numerator retains its sign. In the denominator, there will be that sign change, negative x and negative 1. And you understand why. It's because we are applying the negative and distributing it to the exponential expression. Then we add like terms, okay, for the exponents. 2x minus 2x is 0. 2 minus 4 gives you negative 2. Times 2 to the power, we have x minus x, which is 0. 1 minus 1, which is also 0. And obviously what that leads us to is 5 to the power negative 2 times 2 to the power 0. 5 to the power negative 2 can be expressed as 1 over 5 squared, applying the definition of exponents. 2 to the power 0 is equal to 1, because any base raised to the power 0 is equal to 1, except if the base is non-zero. And then ultimately, what 1 over 5 to the power 2 is 1 over 25. You times that by 1, you still get 1 over 25. Okay, and that is the recipe. Okay, so let's cook.